Hello viewers, welcome back to my channel. Now look at this very simple problem. This is a coordinate geometry question. It's that we should determine the length of the tangent from the point this to the circle this. Okay? Now I want to show us something. If I have that this is a circle, let's assume that this is a circle. Assumption. Let's assume that this is a circle. Okay? And I have that this is the tangent to this circle. This is the tangent to this circle. Don't know how to draw, but let's manage. This is the tangent to this circle. And you know that this from the center to any part of the circumference is called the radius. This is the radius. And the center of the circle, let's call it h, k. And then let's call this as the point of the tangent. Okay? x1, y1, x1, y1. Okay? So we have this. Or let's just call it s, y anyway. Or let's call it s, y. And then this is the starting point. Okay, let's call this the starting point from here. Then let's call this the ending point. That is x1, y1. Right? Now let's just close from here to here. Let's just close from here to here. All right. Now you know that this place is L. This is L, which is the length of this tangent. Let's call this the length of the tangent L. Okay. Now having this, now to find this place, the distance from here to here is simply saying, to find the distance from here to here, you know the distance between 2 points, the distance, let's call it D. Okay, let's call this place D. The distance between these 2 points, let's call it D. Okay. Now normally to get that distance D, you say D squared is equal to x will go to x. That is what? x1 minus h all squared plus y1 minus k all squared. This is this distance from here to here. Okay. Now, if you want to use Pythagoras theorem said d squared is still the same thing as saying L squared plus R squared. I hope you know. And then we are looking for this L. So this L squared is the same thing as saying this one will come here. That is d squared minus R squared, right? So therefore, my L squared is equal to, we have gotten d squared to be this. My d squared is x1 minus h all squared plus y1 minus k, okay, all squared. Then don't forget I have minus r squared here, right? Okay, so the length of the tangent is now given by this formula, the square root of x1 minus h all squared plus y1 minus k all squared minus r squared. So that is how we got that. So that is what we're going to use here. So solution, I'll tell them that the length of a tangent is given by the square root of x1 minus h all squared plus y1 minus k all squared, then minus r squared. Okay, so from here we have gotten our x1, the point given. So the point x1 comma y1 is already given to us as 1 comma 13. So the problem now is just to get the center and the radius of the circle. Before then, we can get it from this equation. The equation given was 4x squared plus 4y squared minus 16x minus 8y minus 36 is equal to 0. If I divide everybody by 4, because I can divide everybody by 4, even without that, we need the coefficient of x squared and y squared to be 1 before we can solve anything at all. So if we divide everybody by 4, we're going to have divide through by 4. So to have x squared plus y squared minus 4y minus 4x minus 2y, then minus 12, right? No, sorry, 9. 9 is equal to 0. Okay? So now, let's go. What do we now have? So this is going to give us, now let us write the standard equation of a circle that said x squared plus y squared minus 2hx minus 2ky plus c is equal to 0. If you compare this, you are going to be having, permit me to solve it here. If you compare them, you're going to be having that this is equal to this is equal to this, therefore this is equal to this. So we're going to tell them that minus 2hx should be equal to minus 4x. This is equal to this. So therefore, my h is equal to minus 4x divided by minus 2x. I'm having 2. Okay, so keep comparing. This is equal to this. We'll tell them that minus 2ky is equal to minus 2. Okay, minus 2ky is equal to minus 2y. So therefore my k will now be minus 2y divided by minus 2y. When anything divides itself is 1. So finally I'm having that my c is equal to minus 9. My c is equal to minus 9. But the formula for c is given by h squared plus k squared minus r squared. That's the formula for c. You can watch my video on equation of a circle. The link is on the description. All right. Okay, circle geometry in general. Okay, so therefore I have that minus 9 is equal to this is h, which is 2 squared plus 1 squared minus into minus 9 squared. So I'm having that minus 9 is equal to 4 plus 1 minus 81. Okay, this one, what am I looking for? Sorry, I'm looking for r. This is r squared. Sorry, that's a mistake. I'm looking for r. Okay, so this is minus 9 is equal to 4 plus 1 minus r squared. So this one go here, this one come here. So r squared will give us 4 plus 1 plus 9. So r squared is equal to 14, right? This and this is 10, 14. So my r is now the square root of 14. So having gotten this, we are good to go. So let us now substitute. To substitute, let me write out what we have. Okay, let me write out what we have here. Let me write it here. So we've gotten that s1 and y1 is this, and then we have gotten that h comma k is equal to h is 2, k is 1. So 2 comma 1, and then our radius squared is 14, because that's what we need. So the length that we're looking for will now be the square root of, let's substitute. Here is x1, that is 1 minus 2 all squared plus 13 minus 1 all squared, then minus 14. Okay, so this is now the square root of this, and this will give you minus 1 all squared plus this one will give you 12 squared, then minus 14. So I'm having that this is the square root of 1 plus 144, then minus 14. So you are now having the square root of 144 minus this is 140, 130, so 129, 129. So that is the length of the tangent. So thank you very much for watching this video. Please don't forget to give this video a like, and then you comment. You can share to your friends as well. If you're a new person, you're watching us for the very first time, please subscribe. We bring you videos on maths, physics, and chemistry. All right, may the peace of the Lord be with you if you're a returning subscriber. Bye bye.